This is the lecture for lesson 30. This lesson we will be solving exponential equations. We'll start with like bases. We will then work to rewrite equations so all powers have the same base. We'll then use logs to solve them as well as natural logs. This first part is going to talk about using like bases to solve exponential equations. And we have looked at a few of these. So when our bases are the same, then the exponents have to be equal to each other. So when I look here, it says if 2 to the 4x minus 1 equals 2 to the 7, well, we have like bases, so that means their exponents, 4x minus 1, has to equal 7, and then we could solve that to find the answer. So for 2, we're going to actually solve those. We have 3 to the 2x plus 1 equals 3 to the third. As long as the bases are the same, we set the exponents equal to each other. Excuse me. So 2x plus 1 has to equal 3. I'll subtract 1 from both sides. I get 2x equals 2. And lastly, if I divide by 2, x equals 1. Looking at B, we have 5 to the 2 minus x equals 5 to the 7x. So again, as long as the bases are equal, the exponents 2 minus x has to equal 7x. I'm going to move this x over to the other side by adding. So I have 2 equals 8x. And now get x by itself, I need to divide by 8. 2 divided by 8 reduces to 1/4. Last one, we have 7 to the x minus 2 over 6 equals 7 to the 1/2 power. So again, as long as the bases are the same, the exponents can be set equal. So x minus 2 over 6 has to equal 1/2. Now we are going to, you can either think about this as cross multiplying, or we can just take this x side. We see that x minus 2 is being divided by 6. So I'm going to times both sides by 6. So I get x minus 2 is equal to 3. And then to get x by itself, I'll add 2 to both sides and get x equals 5. In these next problems, the bases are not going to look the same when we start the problem. So if I look here, 4 to the 2x minus 3 equals 64. They're not the same. But in these ones, we are going to be able to make the one have the same base as the other. So we're going to look at the smaller of the two numbers. So 4 to the 2x minus 3, and we want to figure out, is 64 a power of 4? Well, 4 squared is 16, so it's not to the second power, but 4 to the third power is in fact 64. So I'm going to rewrite 64 as 4 to the third. Once the bases are the same, I can now set the exponents equal to each other, and then this is just like the problem we were doing. So add 3 to both sides, I get 2x equals 6. And then when I divide through by 2, the answer is x equals 3. All right, for B, we have 9 to the x equals 1 over the third root of 3. Well, the smaller number we have is 3. So 9 is 3 squared. So I'm going to write 9 as 3 squared, and I'm going to put the x that's outside. Now, on this right-hand side, we have to think about this, a few different exponent rules. So to bring this into a exponent, the third root of 3 is 3 to the 1/3 power. Now, it's in the denominator. We don't want it in the denominator. We need to bring it to the numerator so that we can solve this. So if I'm going to bring it up across the fraction bar, I then have to make this a negative exponent. So 1 over the third root of 3 is the same as 3 to the negative 1/3 power. So on this left-hand side, 3 squared to the x is 3 to the 2x. I don't need that parentheses, sorry. Equals 3 to the negative 1/3. Now that the bases are the same, I can set 2x equal to negative 1/3. To get x by itself, I'm going to divide by 2. And if I take negative 1/3 and divide that by 2, I get negative 1/6. And then the last one here, we have 2 to the 3x minus 1. And then we have 32. So 32, well, let's think this through. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. So there we go. So we're going to rewrite 32 as 2 to the 5th. Once the bases are the same, we can set the exponents equal to each other. So 3x minus 1 equals 5. I will add 1 to both sides. I get 3x equals 6. Divide by 3 to get my final answer of x equals 2. Third type of problem we're going to work with. There is no way to make these have like bases. 19 to the x equals 143. There's no way to get 143 to be a power of 19. It just doesn't work. So when there is no way to make them have a like base, what we are going to do is we will log both sides and then use some properties of logs to help us get x by itself. So what I'm going to do is I'm going to log this side and I'm going to log the other side because whatever I do to one side, I have to do to the other. Now, properties of logs tell me that I can bring an exponent down front. So I'm going to make this x times log 19 equals log of 143. And then I can get x by itself by simply dividing both sides by log 19. So I have log of 143 over log of 19 is what x equals. So what I would have to do is I would go to my scientific calculator or Desmos, so I can type this in, and you should get 1.69. After I solve all of these, I will show you my Desmos slide just so you can see how I type them in. All right, for B, we have 4 to the x plus 1 equals 6 to the x. So looking at this right now, again, 4 is 2 to a power, 6 is, there's no number that gets it to a power. So I'm going to log both sides. So I will log this side. And if I log the one side, I must log the other side. Now, both of these have powers here. So in both of these, I have to bring this power down front. So x plus 1 is going to be in front of log of 4, and x is going to be in front of log of 6. Now, this problem has more than one x. So this problem is going to be a little more involved. So on this left-hand side, I need to distribute this out. So it's going to be x times log of 4 plus 1 log of 4 equals x log of 6. Okay, I need to get the x pieces on the same side, the numbers on the other side. So I'm going to move this x log 4 to the other side by subtraction. So 1 log 4 is just log 4 equals x log 6 minus x log 4. Now, what I can do is I can factor out the x because it's a GCF. So I'm going to take the x out of both of these pieces. Log 6 minus log 4 is what's left. And then to get x by itself, I can divide by log 6 minus log 4. So I have x equals log of 4 all over log 6 minus log 4, which I will type into my scientific calculator. I will show you in Desmos here in just a second what that answer looks like, but I've got 3.42. All right, next one is going to be kind of similar. We've got 5 to the x minus 3 equals 13 to the x plus 2. So this one, again, is going to have an x on both sides. So we're going to have to get the x's to the same side, factor out the x to be able to solve and divide. So first thing first, I'm going to log both sides. So 5x minus 3 equals log of 13 to the x plus 2. So I'm going to bring that power down front. X minus 3 equals log, or sorry, not equals, times log of 5 equals x plus 2 times the quantity of log 13. So I'm going to distribute this out. So x times log 5 minus 3 times log 5 equals x log 13 plus 2 log 13s. Now, to not confuse, I'm going to do a different color here. I'm going to bring the x to the left side, so minus x log 13. And then I'm going to add the 3 log 5 over to the other side. So I'm moving the x's to the left side and the numbers to the right side. So I'm going to have x log 5 minus x log 13 equals 2 log 13 plus 3 log 5. All right, on this left-hand side, I can take out this x. So log 5 minus log 13. And the right-hand side, I can leave as is. So that to get x by itself, I can divide by this log 5 minus log 13. To get my final answer is 2 log 13 plus 3 log 5 all over log of 5 minus log of 13. I will show you in Desmos how I would type that in. Give me just a minute, but you should get negative 10.42. And on the next slide, I will show you how I type those in Desmos. All right, so here you can see my Desmos screen. When you're doing just one log divided by another log, pretty straightforward. Once I get to having more than one piece in the numerator or the denominator, I have to make sure that I'm using parentheses to make sure that everything in my numerator stays in the numerator, everything in the denominator stays in the denominator. So when I look at the second one, log of 4, and then I hit divide, and I immediately opened a pair of parentheses because I had two terms that were on the denominator that had to stay down there. And then on 3, I had two terms in the numerator. So I made sure I put parentheses around those two before I hit the divide by button, and then immediately open parentheses for the denominator because, again, I had two pieces down there. Okay. So the last type of problem we're going to work with is now exponentials with an e. So instead of using the basic log, we're going to now do natural log because natural log undoes e. So we're going to follow that same process. So if we have e to the 1 minus 8x equals 41. What I'm going to do is I have to natural log both sides in order to be able to get the exponent piece down. So natural log both sides, and then I'm going to follow that same process of bringing the powers down and moving the numbers away, getting x's together, and solving. So on this side, I've got 1 minus 8x times the natural log of e equals the natural log of 41. Well, that's nice. The natural log of e is just 1, so this piece just cancels out. And I have 1 minus 8x equals natural log of 41. Okay, so to get x by itself, I first need to get rid of this positive 1, so I'm going to subtract 1. So I have negative 8x equals natural log 41 minus 1. And then that whole result needs to be divided by negative 8. So when I type it in Desmos, I'm going to put that numerator in parentheses and then divide by negative 8. So natural log 41 minus 1 in parentheses divided by negative 8 is going to give me the decimal negative 0.34. And again, on the next slide, I will show you what that looks like in Desmos. Working with b, I have 2e to the 5x plus 10 equals 17. So the first thing I want to do is I need to make sure that the exponential piece is by itself. So what I'm going to do is I'm going to subtract 10 from both sides. And I have 2e to the 5x equals, that's going to make 7. And then I want to get rid of that 2 in front, so divide by 2. So e to the 5x equals 7 halves. Once the exponential piece is now by itself, now I can natural log both sides. Natural log of e to the 5x equals natural log of 7 halves. So we're going to bring this power piece down front. So 5x times the natural log of e equals the natural log of 7 halves. Okay, well that's nice. Natural log of e is gone. It's just 1. So I have 5x equals the natural log of 7 halves. So to get x by itself, I'm just going to divide by 5. So x equals the natural log of 7 halves, all divided by 5. And this should give you the decimal 0.25. For c, we have e to the 0.08x minus 1.4 equals 42. So the first thing I'm going to do is add that 1.4 to the other side. So I have e to the 0.08x equals 43.4. So that the exponential is by itself, and I can now natural log both sides. So when I natural log this side, the exponent comes down. 0.08x times the natural log of e equals the natural log of 43.4. Natural log of e, easy, cancels out, turns to 1. So I have 0.08x equals the natural log of 43.4. So to get x by itself, I'm going to divide by 0.08. So x equals the natural log of 43.4, all divided by 0.08. And for this one, I got 47.13. So on this slide, I just wanted to show you how I typed all of these in Desmos. The first one, because there were 2 pieces in the numerator, I put them in parentheses before I divided by negative 8. For the second one, in order to take the natural log of 7 halves, I had to put the 7 halves in parentheses. And then the last one didn't have to have any parentheses because it was just a natural log of a number over another number.